Hello, this is module H about SLAAC and then DHCP version 6. So SLAAC it stands for Stateless Auto Address Configuration. Then DHCP it's uh, Dynamic Host Configuration Protocol version 6 or for version 6. So in this module, we're going to actually look at how devices can actually assign or be assigned IPv6 addresses automatically. So we have what you call SLAAC, and then we have DHCP. So here it involves you configuring the pool, and then the pool service it generates, so it gives out addresses automatically. But when it comes stateless, now here the information that is given out and then the other information, the device is instructed to look for other information from somewhere which you're going to see. So in this module, these are the areas that you're going to cover. IPv6 Global Unicast Address Assignment, then stateless address configuration, and then we have dynamic host configuration protocol version 6, then how to configure the HCP version 6 server. So with global unicast address, I have no Ethernet port on my laptop. I would have demonstrated that. But this is the interface in case you want to assign the IPv6 IP address onto your computer, where you have to do. I hope all of you guys, you know what an IPv6 address is, the structure, the format. So it is here, and then this is the prefix length, then this is the default gateway, this is the preferred DNS server on the network. So we have IPv6 host link local address. If automatic IPv6 addressing is selected, then the host will use an Internet Control Message Protocol version 6, that is ICMP, Router Advertisement message to help each auto configure an IPv6. So the IPv6 link local address is automatically created. By host when it boots, and the Ethernet interface is active. So this one here, it is auto-generated. It is always auto-generated. The interface did not create IPv6 global unicast address in the output because the network segment did not have a router to provide network configuration instructions for this. That's the reason why the IPv6 address is not generated. This global unicast address is not generated here. It's empty. It's because that this PC here, it's not connected to the router to instruct this PC to auto-generate it. Note the percent and the number at the end of the link local, which is this, the percent and the number of this is known as zone ID or scope ID and is used by operating system to associate link local address with specific interface. Note, DHCP is defined by this. By default, IPv6 enabled router periodically sends ICMP router advertisement, which simplifies how a host can dynamically create or acquire IPv6 address. So with dynamic global unicast assignment, we have what we call stateless and then stateful. So in stateless, that is where we expect the SLAAC only. Router sends router advertisement message providing information, all the IPv6 address information, that is, be it network prefix, prefix links, and default gateway information. So hosts use the router advertisement information exclusively for all their addressing, including creating their own global unicast address, that it can actually instruct the PC to create its own IPv6 address. Then we have SLAAC and with DHCP, that router advertisement messages provide IPv6 address configuration information to hosts and inform them to contact a stateless DHCP version 6 server for additional configuration information. That some information can be obtained from the router and then other information from the server. So hosts using router advertisement information to create their own unique global unicast address and get additional information from DHCP server. Then lastly, we have DHCP version 6 server, which is stateful DHCP. So router advertisement message informs host to contact stateful DHCP server or DHCP enabled router for all IPv6 configuration information except the default gateway. So hosts contact the DHCP server to acquire all their IPv6 address information, or hosts obtain default gateway information from the router advertisement message. So there are three router advertisement messages where we have A flag, we have A flag, we have O flag, which is other configuration, and then we have managed address information here. So with A flag, the address of auto configuration, this is auto configuration flag, signifies to use stateless address auto configuration, stateless address auto configurations. Auto configuration. So it's stateless address auto configuration to create IPv6. Then we have others, other flag. So other configuration flag signifies that additional information is available from the stateless DHCP. Then the managed address configuration flag signifies to use stateful DHCP server to obtain IPv6 address. So here how the flags are flipped. That with SLAAC only, it's this because it's stateless address auto configuration. It's the one that is going to be flipped to 1, and then the others, and then managed, they are flipped to 0. Then when it comes to where we have SLAAC and DHCP, it's the stateless auto address configuration on, and then the other configurations on, then the managed off. Then when it comes to stateful DHCP, the auto configuration, it's off, and even others, it's off, it's only managed configuration, managed address configuration that is going to be turned on. So this is SLAAC. I'm not going to go into details because I've already explained whatever that is here in SLAAC overview. It's what I've talked about. A bit to add that with SLAAC, remember, it's the messages, the router advertisement instructing the end devices on how to get the IPv6 address. With this, every 200 seconds, the router advertisement message, it is always sent. It is always sent. But there are other scenarios where a host can also send the router solicitation, a request message requesting for router advertisement. Then the router is going to reply that. So here we have a scenario enabling SLAAC how to enable the SLAAC on the network, and then the information that is going to be added there. So there is router 1 with gigabit Ethernet 001 has been configured with indicated IPv6 global unicast address and then link local address. Where are they? We have the link local address as this one here, then global unicast or the subnet, it's this. This is the IPv6, then this is the local address. And then we have the IPv6 all nodes, this address that every time the router wants to communicate to all computers on that network, it will have to use this multicast address. Multicast address. So when you're dealing with IPv6, do not forget to use this command here, IPv6 unicast routing, to enable the IPv6 forwarding of IPv6 packets. So for all routers, the other one, it was for all nodes, that if it's a computer, now the end device trying to connect back to all the routers on the network, it uses this multicast address, FF0002, then there is a 2. Then we have this verification command, show IPv6 interface. Once you run this command, you can select, actually filter, section joined. So with joined, as you can see, we have this one here for all nodes. Then we have this one here for all routers. All routers. That was SLAAC, the SLAAC method only, or SLAAC only method. So as you can see, it's on the auto address configure stateless address of the configuration flag that is turned on, and then the rest other configuration and managed address configurations, they are all turned off. So we can use ipconfig on the PC to be able to verify the addresses that are assigned on our PC. So after doing all that, this PC is assigned with this information. This is the IPv6 address. This with the address that is auto-generated. Have the link local, which is this. Then we have even the IPv4 address. This is a paper, then subnet mask, and then the default gateway. Okay. So this is the command for us to use to do the verification of all this information. To deal with IPv6, they want to verify the IPv6 address, link local, IPv6 address, then all this information, because it cuts across. It's not that this is for IPv6 or it's IPv4. No, it cuts across. So we have the ICMP version 6 router solicitation messages. Now these ones are actually initiated by the PC. Router advertisement, it's direct from the router, but solicitation, it's from the PC. It's same as the request. If the PC, because let's say the PC it has just booted, then it has to send a request requesting for the router to instruct or for instructions on how to assign IPv6 automatically. The host process to generate interface ID. We have this host process to generate interface ID. So we have random generated and then extended unique identifier 64. So with randomly generated, 64-bit interface is randomly generated by the client operating system. So it's the operating system that auto-generates this number. But remember, the IPv6, it has two portions. We have the prefix And then we have the interface ID. So the prefix, it is known for randomly generated. Then the interface ID, it is the one that is the prefix, it is known, but when it comes to interface ID, it's the one that is auto-generated by the operating system. So it depends. So this is a method now used by. So if it is Windows 10, then you expect that it supports that. Then we have extended unique identifier 64. The host creates an interface ID using the MAC address. So here we're going to use the MAC address to generate the 64-bit. This one here, the interface ID. And now the MAC address for it, it is equivalent to 48, meaning that you are left with 16. So the 16 bits here, it's a standard. We have in between the 48, that is 24 here, and then 24 here, in between here. We have to add this the extent FF, then E. FF, E. But don't forget that the 7th bit, it has to be flipped. If it is a 0, it is flipped to 1. If it is a 1, then it is flipped to a 0. So those are the, that is the syntax, or that is the process. So we have two ways, randomly generated and then extended unique identifier. So randomly generated, it's the role of the operating system. Then when it comes to extended unique identifier, the MAC address, it is edited, altered. Yeah. So we have still in SLAAC, we have what you call duplicate address detection. That SLAAC host may use the following, the DAD process, to ensure that the IP address that it is yet to actually assign to its interface, it is checked. It is checked to make sure that IPv6 address is not assigned anywhere else. So the host sends the ICMP neighbor solicitation. The host, it sends the neighbor solicitation message with a special constructed solicited node multicast address containing the last 24 bits of IPv6 address of the host. If no other address responds with the neighbor advertisement method, then the address is virtually guaranteed to be unique and can be used by the host. If the neighbor advertisement is received, then that it means the address is not unique, it is already assigned somewhere else. And the host must generate a new interface ID by dropping the other one. So we have IPv6 operation steps. Regardless when router advertisement indicates to use DHCP or stateful DHCP, there are these 6 steps. Step number 1, the host sends, as you can see, the host, a host, it sends router solicitation message, then the router responds with router advertisement. A host sends DHCP solicit message, and then the DHCP server sends the DHCP server responds with an advertise message, and then the host responds to the DHCP server. Lastly, step 6, DHCP server sends reply message. So this is what is going to happen. That it's the PC that sends the solicitation message, and then the router, it's going to send the router advertisement. Then the router advertisement, it's going to actually have whether, because here it's a general, it cuts across whether it's stateless or stateful. Stateless, it works with SLAAC. Then stateful, it works alone. It's a standalone. So for example, for stateless, after the two steps here, then automatically with router advertisement, it's going to come with half of the address information, and then it is assigned to the PC. And then the other part of information, it is to be picked from the server. Even when it's DHCP, stateful DHCP used, that the PC is going to first consult the router, and then the router replies with advertisement. With the instruction advertisement, it's going to contain the instruction, consult the server. And then the PC is going to send a request to the server, and then the server replies back with an advert, and then the PC is going to request the information in that advert, and then once the PC receives the request, it will acknowledge the request, and then the PC uses the requested IPv6 address information. So this is stateless. I've already exhausted this explanation in the previous slide, that we have stateless DHCP version 6 operation. This router extracting PC, yes, half of this information from the router, and then the other information from stateless DHCP server. But when you look at this, is that the stateless address auto configuration is on, and then other configurations also on, but managed off, turned off. Then stateful, as you can see, still the router, it can advertise, but when it advertises, we expect the instructions on how the PC is supposed to auto assigns the IPv6 address information on that very computer. Even when you look at the flags that are turned on, is that the auto configuration is off with a 0, then other configuration is 0, and then managed address configuration, it is turned on. So you just get time, go through that, you go through those slides, you read through. So here where we have the other here, that you have to be on an interface, that very interface that you've configured, and then you turn on the other configurations, as you can see. Then for managed, still on that interface that connects to the end device, and then you got IPv6 and the managed config flag on, so that the devices on that network are to receive addresses automatically. So DHCP version 6 router roles. Cisco IS router routers are powerful device. In small network, you do not have to have a separate devices to have DHCP version 6 server and client, or even relay agent. So the iOS router can be configured to provide the server service. So specifically, it can be configured to be one of the following: that route of yours, it can serve as the server, it can serve as the client, it can serve as a relay agent. A relay agent. So the relay agent, it provides DHCP version 6 forwarding service when the client and the server are located on different networks. So it will help to bridge the network. The DHCP relay agent, it bridges the network 1 and network 2. The client and the server not on the same network. So these are the steps configuring stateless. So last time we looked at IP, how to configure DHCP version 4. Now this is 6. But there are 5 steps to configure and verify router as stateless. The stateless, it means that part of the address, the info IPv6 information, it's within route advertisement, and then the other information it's from DHCP. So there are 5. You enable IPv6 routing using IP unicast. Step number 2, you define the pool by using IPv6 DHCP get the pool. Step number 3, you configure DHCP pool with option. Now we have DNS server, you state the DNS server, the domain name. Then step number 5, you bind the interface to the pool IPv6 DHCP server. So you have to attach the pool that you've created to an interface. And then you make sure that you turn on the other configuration flag. Then step number 5, verify that the host have received IPv6 address. Okay. So there are here the steps, there are 5 on what you're supposed to do. IP unicast, then step number 2, configure the client router to create this local IPv6 enabled this. Then IPv6 autoconfig briefly with this, then yeah, IPv6 DHCP interface, this. You should be having the example. This is stateful now. Stateful. Almost the same, but all the information it has to be either in router advertisement or from the so the unicast, as you can see, IPv6 unicast, then IPv6 pool, the pool name, then configure the pool that includes address prefix, domain name, DNS. This is DNS, not DHC, DHS, and other information. Then you bind by using IPv4 under the interface. IPv6 DHCP server, and then you put the pool name. Then after that, you go ahead and put IPv6 and managed configuration, so that all the information should actually be picked from the search pool, and then you can verify last and make sure that all the interfaces or all the end devices have received. So these are still the same on what we supposed to do, not you're supposed to do. So DHCP version 6 server verification command, I show IPv6 DHCP pool. So this, as you can see, it is stating the pool name, and then the prefix, as you can see, the lengths, the prefix lengths, the domain, the DNS server, domain name, and then the active clients. That the active clients, there are 2. There are 2. So we have even show IPv6 DHCP binding to see those addresses that have managed to pick the IP addresses. The IP addresses. So the client, as you can see, we have this is the client, we have the second client. Because in previous we said that the active clients, there are 2. Now where are they? They are here. There's this, and then there is this. But this one here, when you look at this, this is a link local address. But the global unicast address, it's this one here, and then this. So this is the other command, as we said. I say show IPv6 DHCP binding. So it shows exactly the IP addresses that have been issued out, ones that have been issued out. So these are the client. This is client 2, this is client 1. So this information is maintained by Stateful DHCP server. Stateless DHCP server would not maintain this information, because for stateless the information it keeps on changing, but for stateful it is always that, until the lease expires. Then we have the DHCP relay agent. The relay agent, it's that router that bridges the network, because we have network A here, network B. So this is the client, and the client wants the needs IP address from the stateful DHCP servers. You can see it's on router 3. So this router, it will allow the message, the multicast message, to close this router to reach router 3 for address or DHCP address information. So how are we going to do that? Because since the direction it's this, the client is on this interface, so we shall actually, all we need is just to call this interface gigabit Ethernet 00, and then IPv6 DHCP relay destination. Now, where is our DHCP version 6 server? It's on this interface here. So it is 2001 db8 acad1.2, which is this. Then even you can go ahead and put the interface, but ideally this is enough. So that in case this PC needs the IPv6 address, it has to send the router solicitation direct through router 1 to router 3. Then after that, you verify that the DHCP relay agent is operational with the show IPv6 DHCP interface and show IPv6 DHCP binding. So this is the show IPv6 DHCP interface. You can see the relay destination, it's this via this interface. Then we have this, the binding. And the binding, so it's one client so far, so far. Yeah. So that it makes it backs end of our session.